Okay, picture everything you learned in middle school science about Jupiter. Got it? Well, you can probably toss most of that right out the window. For decades, we've pictured the biggest planet in our solar system as this massive ball of gas with a dense, perfectly solid rock at its very center. But some recent, honestly mind-blowing discoveries have completely shattered that textbook image. In this explainer, we are diving into a wild cosmic mystery. We're talking violent planetary feeding frenzies, a literal playground bully, and a core made of dissolved rock that scientists actually compare to a bowl of chili. So it all starts with one really fundamental question. Does Jupiter actually have a solid core? We've always just assumed that gas giants had a solid rock right at the center, kind of like the hard seed inside a peach. I mean, Earth has a solid core, so it made perfect sense that Jupiter would too, just scaled up. And figuring out what lies at its center is absolutely crucial, because it's basically like winding back the clock billions of years to see exactly how planets are born. But to actually answer this, we needed a completely audacious space mission, one that forced us to question absolutely everything we thought we knew. Enter the Juno space probe. After hurtling through the pitch black of space for 5 whole years, it finally arrived on July 4, 2016, and it was moving at a blistering 165,000 miles per hour. Let that sink in. That is literally blindingly fast. And this was an incredibly dangerous maneuver, too. The probe had to thread the needle perfectly, flying fast enough to cross the vast, empty solar system, but then slamming on the brakes at the absolute last second just to be captured by Jupiter's massive gravity without crashing. Now, Juno wasn't just there to take pretty pictures of the swirling clouds, though let's be real, it definitely did that. Its primary objective was way more intense, to peer deep into Jupiter's dark heart and map the unseen. You see, if Juno found a solid core, it would mean Jupiter originally formed as a rocky planet, kind of like Earth, and then just kept growing. But if it found no core, it could mean Jupiter somehow skipped that rocky stage entirely. But that raises a pretty massive problem. How exactly do you look inside a giant swirling ball of opaque gas? Well, the answer is gravity. As Juno sped around Jupiter, dipping incredibly close to the cloud tops, it mapped the planet's gravitational pull. Think about it like this. If Jupiter were just a perfectly smooth, solid ball, Juno's flight path would be completely even. But instead, denser parts of Jupiter's interior literally tugged on the spacecraft, creating these tiny little speed spikes, almost like hitting a cosmic speed bump. By tracking those exact speed fluctuations, engineers back on Earth were able to build a highly detailed 3D map of the unseen mass hidden deep beneath the clouds. And when scientists finally saw that shocking gravitational data, oh man, their textbook models completely failed. They fully expected to find what they called an avocado, basically a neat, solid pit of metal and rock right down at the center. But instead, the gravity map revealed this fuzzy, amorphous mass. The core wasn't a solid pit at all. It was this bizarre, soupy mix. The researchers literally said, and I absolutely love this quote, "We thought we were going to find an avocado. Instead, we found a bowl of chili." They discovered a fuzzy, amorphous zone where rocky material and fluid hydrogen are completely, thoroughly dissolved together. It's essentially a cosmic chili con carne. This was a type of planetary core no one had ever seen in the history of astronomy. It meant every single textbook model of Jupiter's interior had to go straight in the trash. Okay, but to understand this bizarre chili core, we really have to look at the ticking clock of the early solar system. When our cosmic neighborhood first formed, it was just a chaotic, swirling disk of gas and dust. But our young sun was highly active, constantly throwing off these violent bursts of radiation. This meant the early gas disk only survived for about 4 to 5 million years before the sun literally blew it all away into deep space. And in cosmic terms, 4 to 5 million years is nothing. That is an incredibly brief window for a giant planet to form. Which brings us to the real head-scratcher. How did Jupiter manage to get so massive, so incredibly fast, before its building blocks simply vanished into space? If it had to wait for distant large rocks to randomly bump into each other and fuse together the traditional way, it would have taken 100 million years to form. But again, the clock ran out in just 5 million. Jupiter had to somehow cheat the system to grow this fast. And the answer to this mystery is a cosmic cheat code called pebble accretion. Instead of waiting for massive planetary rocks to smash together, the infant Jupiter started gobbling up tiny, centimeter-sized pebbles that were just drifting freely in the early solar system. Because they were so remarkably small, the growing planet's gravity could just effortlessly sweep them up in massive, massive quantities. It's a total snowball effect. First, those tiny centimeter pebbles clumped together to rapidly form a huge core. And because it was growing so remarkably fast, its gravitational reach expanded, which let it aggressively absorb larger rocks in an absolute feeding frenzy. Finally, once the core was massive enough, its immense gravity ripped in all the surrounding hydrogen gas right before the young sun could blow it away. This insatiable, pebble-fueled binge eating built a core that was a staggering 20 times the mass of Earth in record time. It grew 1,000 times faster than traditional models ever allowed. But, as you might guess, this hyper-accelerated, incredibly violent growth came with a pretty heavy consequence for the core itself. The sheer impacts of absorbing all those early planetary bodies were so violent, and the crushing pressure from all that captured gas was so unbelievably intense that the solid rock simply couldn't hold its shape. It literally broke down. The solid rock dissolved into the surrounding fluid, creating that fuzzy, liquid-like chili soup state that the Juno probe detected billions of years later. The original solid seed of Jupiter was completely, entirely obliterated. As the researchers noted, the core material actually dissolved and mixed directly into the heavy hydrogen atmosphere, trapped forever under thousands of miles of crushing clouds. It's just a fascinating, almost terrifying look at planetary destruction happening from the inside out. But hey, the story definitely doesn't end there, because we have to ask a much broader question. What happens to the rest of the cosmic neighborhood when a massive giant forms this rapidly? You really can't have a giant vacuuming up all the available material in the entire solar system without it having a severe impact on everything else that's just trying to grow nearby. In short, Jupiter became the absolute bully of the playground. If you were drawing this in a stickman animation, you'd basically draw one giant, chaotic stick figure violently shoving all the smaller ones right out of the sandbox. Because it grew 1,000 times faster than its neighbors, its immense gravity physically shook smaller infant planets. It lifted them up and shoved them out of the material-rich disk, essentially starving them of the pebbles they desperately needed to grow. And this bullying completely reshaped our destiny. If it weren't for this gas giant hoarding all those pebbles, computer simulations show a wildly different reality. We could have ended up with a solar system packed with 100 smaller, Earth-sized planets instead of the 4 distinct rocky inner planets we actually see today. Jupiter essentially cleared the entire board. And what's really wild is that Jupiter is actually still bullying us today. It's an incredible example of the cosmic butterfly effect. Even from hundreds of millions of miles away, the gravitational presence of this massive gas giant subtly, quietly tugs on Earth's orbit. Over long periods of time, these tiny gravitational nudges can drastically alter our climate, driving extreme cycles and even pushing our planet into deep ice ages. In fact, we operate on this massive 405,000 years cycle. Every 405,000 years, like absolute clockwork, Jupiter and Venus effectively gang up on us gravitationally. They pull Earth's orbit into an even greater ellipse, violently stretching our path around the sun. This radical stretching makes our hot weather hotter and our cold weather incredibly colder, completely altering the climate history of our world. So as we wrap up this explainer, it leaves us with one final, profound thought. How completely different would our own planet's fate be if this insatiable fuzzy-cored giant hadn't dissolved its heart and violently taken over the cosmic playground? Without Jupiter's rapid growth and subsequent bullying, the Earth as we know it and the life on it might never have existed at all. We just might owe our entire existence to a fuzzy bowl of cosmic chili.